We do have the check-in working. If you did not check in yet, you can check out before you leave. All right. How's everybody doing tonight? Week 10. And tonight we're going to be going over pointers and a couple things I want to go over on announcements. Tomorrow is enrollment for summer 1 and 2. I did bring one of my Internet of Things devices here tonight to show you what I'm doing. This is a proton particle Wi-Fi device that's connected to an LED with a lithium battery. And there's an app called Blinks that we use to use Python to code in. And this one only will show temperature, whatever message you put on here. Right now it's a message about tap temperature, show rocky temperature, or AccuWeather temperature. Type tap text again, back to the message. So once it's set up, it can then be used anywhere. The lithium battery, depending on how many times you check AccuWeather, which I have it checking every 15 minutes or something. You got to check in every hour or 2 hours. It probably lasts about a month and a half, the lithium battery would. By checking it every 15 minutes, I think it lasts about a week and a half, 2 weeks, something like that. Anyway, and you can get larger lithiums. This whole project only costs about $35. And this is the brains of it here, which is the photon device. I'll be doing 4 of these projects. This one, and then the other one we'll be doing is, show you here. So we'll do motion sensor, like in the Ring doorbell today with the video Ring, one of those you've probably heard of. Part of that's a motion sensor along with the video. In all of these, we're using the photon sensor, which is this one right here. Hold up, I'm just showing you the one I just take over there. And then this is a Arduino motion sensor. And then this one behind the scenes on this control servo is a photon, and then it has an actuator arm that moves every time it checks AccuWeather. It will tell you what the weather is. And the actuator arm will move to a certain picture, tell a person what to wear, possibly before they leave the house. Wearables. I'm actually replacing the wearable one with the one I've shown you tonight, the LED one. I think it's more practical for most students. Not to say wearables aren't, but it's the same concept, by the way, wearables would be. I can control text and whatever I want to show up on the LED. This one, it was controlling the circular light, circular LED. On that one, you can actually take it and do it. There's one of the labs that actually you can make like a, not Terminator. What's the flying suit? Thank you, Iron Man. You can make an Iron Man light type of thing. But anyway, it's cool, but it's not real practical. That's more practical. And then the other one's the temperature reading. Temperature reading, all it does is it does what's called a particle push on all these. That pushes it for a trigger notification. The trigger notifications are pretty much written in Python. And so you'll learn by each project, one per Saturday, what Python code you need to use to control that device or to read that device. In this case, we're reading. In this case, we're controlling. In this case, we are reading from weather, location, and then controlling the actuator. And this one is reading only. All 4 of them, though, sending notifications. And I'm working on getting grant money for each project. Each project's not real expensive. It's about $35, $40 max. for the project, so it's pretty reasonable priced. Most students could afford it, but some might not be able to. And so I want to be able to have that cushion there just in case. But what's cool about it, each Saturday when you'll come in, 7:30, check in. We'll start at 8, finish up around noon, and you'll take home a completed project. Each project, by the way, will be in one of these fancy, well, these are really cheap boxes. I found these are the best boxes for IoT. What they are is they're 4x6 photo holders. Found them on Amazon, and you get like 20 of them for like $8. But it fits really nice, compact-wise, as far as portable for your IoT devices. So all your IoTs are basically in this, except for the second one. That one is a box frame I already bought at Michael's. It's a shadow box frame that puts in the back of the piece of paper with the drawings on it, and then behind it is the actual actuator for the sensor, which is in this case just reading a AccuWeather website API, and then moving the servo arm to wherever the location might be. So anyway, we'll start registering tomorrow. I have had probably about 8 to 10 folks outside RBC that have said they're registering. So if you want to register to be in, it's going to be in this classroom. So we're going to set 20 in here. I'm guessing it'll fill up pretty quick if I was to guess. So if you want to take, it's only 3 credits. It's not really a requirement for any courses you take here or any certificates or any degrees. It's just a cool course you'll probably need if you're going to go into programming as a career, because one of the stats in the on the website here for the RBC IoT.app gives that currently, right now, IoT development is the #1 development when it comes to IT stuff in businesses. $60 trillion invested in IoT by the next 15 years, according to GE. And then every business is looking into it. I was talking to somebody before class when it comes to inventory, because it does a really good job on inventory control. People miss stuff, humans miss stuff, whereas robotic and actuator arms and sensors are less likely to miss stuff when it comes to inventory in shops. And so one of the examples I read last semester was Harley Davidson instituted IoT, and all their in manufacturing shops last year and saved like $65,000 the first quarter in loss that they were losing because they forgot to order something. They didn't have to wait when the customers would just say, no, forget it, I don't want it, or something like that. So it's, save a little money. So one of the things we'll talk about too, which is security in IoT, on purpose, because it's so new or fairly new. It's kind of the Wild West when it comes to security. And so a lot of companies are having to figure out ways to wrap it with security. We'll talk about that, ways to do that. And then everybody's familiar with the wearable market, with your watches, your shoes, your sensors, heart rate. They even have a ring now, I think, that's IoT, where you can wear it and it keeps your heart rate or something like that. It's pretty popular. So anyway, it's a big market. You guys know that. But one of the lesser programming courses in the U.S. is in IoT. It's very underrepresented in colleges as far as offering IoT. So hopefully it'll be a good course for students to where it can give them the skills they need to, at least when an employee asks, have you programmed anything IoT or you're familiar with IoT? You can say, yes, I have. I'm familiar with it and done some stuff. And we'll be using the #1 products on the market right now, which is a particle photon. It used to be Arduino for years. The last 2 years, Particle's taken over, and Arduino's still on the scene when it comes to the sensors. And I don't know if you've heard of the Particle website, but Particle gives developers like yourself 250 projects at no cost, because it does have a price They do make money, you know, not just off the hardware, but one of the devices they sell is a cellular. Instead of Wi-Fi, it's cellular, and then they sell data plans to where like parks and recreations can set up sensors to determine how many people go in and out of the park throughout the day. Buildings can set up sensors to do that as well. But these can be freestanding devices to where they can work through the cloud and get data and charged every night or every month or whatever. And so prototyping is through the roof when it comes to these guys. And again, their market share right now is the number one market share through Particle. But they are offering a lot of free stuff for developers to get them hooked and trained with Particle, because when they get hired at companies, they know the developers are going to be like, well, Particle's what I've used, and that's going to help them in the long run probably. So anyway, pretty cool stuff. Questions on IoT? All right, next is jobs. We talked about summer 1, summer 2 courses. The next tab, I want to bring up the My Receive website. A couple job postings that are still open. One's a fairly new one, which is the seasonal informational tech job from Rock River Water Reclamation District. It is an 8 to 4:30 job, half-hour lunch. Duties would be like preparing electronic equipment for salvage, machine inventory, existing tech with cabling, minor hardware and software tasks. Qualifications: 18 years old, valid driver's license, suitable driving record, enrolled in current fall semester of college, or you will be enrolled in fall semester of college. You'll need to pass a post-offer physical and drug test, $10.25 an hour. You're seasonal limited 599 hours within 12 months of the period of time. And so there's a link to the job application that was just given to me this week, or last 3 days actually. So it's still open. And as far as I know, I've not been told, I was not aware of any fill on this as a programmer analyst position on Rock Valley College's campus here. So those 2 positions are still posted and available. On Saturday, this last Saturday, in here we did a learning coding with robots workshop with local ministers. We had about 10 ministers with 10 young people they brought. And one of the things that was granted, we put in a grant last year. I put in a grant last year for this workshop for $30,000 for Northern Illinois to hopefully grant us some money to buy these Ozobot to give to at-risk youth or families who couldn't afford an Ozobot. Long story short, we were granted the money in November of last year. We're now starting to institute the actual workshops. It's from K through 8. And so we did a workshop with some ministers and their folks to where they can go back to their churches and tell their parishioners about it, but then also they could offer workshops at their location if they wanted to as well. So real quick, after this ad talks about it. So if you know anyone in K through 8, I'm going to tell you in just a second where they can go to register, where your parents can register for them, or if you have kids that age range, they can register.
Computer Science Department. The Learn Coding with Robots workshop is designed to introduce the young churchgoers to the Ozobot robots as a means to develop critical and creative learning skills, as well as get hands-on experience in technology. RVC Associate Professor Chuck Conkle says this partnership is a great way to get kids interested in STEM at a young age.
The reason we use it is with our Hour of Code movement to get folks to try coding. And so today we have local pastors and the parishioners here today to learn coding and have fun with robots.
Taking classes at Rock Valley, all of those classes have had a big impact. What Rock Valley offered coincided exactly with the route that I wanted to take professionally. Rock Valley.
So if you just remember, well, I'm going to have it on myreceipt.org's website, but if you just remember RVC Hour of Code, over on the right side, there's an Ozobot link. If you click on that, you can go to Learn Coding with Robots. It'll redirect to the new curriculum page for the grant that was granted. And it goes over, this is a curriculum we used Saturday, and it was the first time we used it and went pretty well. We go over coding introduction and computer science, what the Ozobot is all about. Ozo codes, which is line drawing coding, where it can follow lines of code and then also can follow different colors of code to do like left turns, right turns, left jump, forward, back, things like that. And different, even cool codes like, the moonwalk, just one of those, tornado, twist, what's another one? Turbo, I think is one of them. So different codes, but then they can go to Ozo Blockly. It's actually, Ozo codes is off screen. Ozo Blockly is on screen. And basically they code through drag and drop and backend JavaScript and put the robot on the screen, and it pushes the light nodes to the robot. And then when they put it on the table, it follows the commands they just put in the code. And that covers everything from basics, forward, left, right, colors, to advanced level, where it gets into iterations and loops and pointers and counters, like 120 plus hours of coding that they can learn outside of the workshop that Ozobot offers. And then group games, they did not have time to do Saturday, so they came in a little bit late. And then here's all the workshop dates. We're starting in April, 2 dates per month, from 10 to noon on most dates. And then it's going to meet in here. And then here's the curriculum for people just have to register. Once they sign up, it'll redirect them to an Eventbrite to choose a date that they want to attend. So if you know anyone K through 8, that brother, sister, niece, nephew, that because I did just a real quick survey of students in the session Saturday. There was only 2 out of the 10 that had any coding courses in their school at all that they knew of anyway. The 2 that did were private schools, which that makes sense. Like Lutheran was one, and Belvedere. Belvedere is a pretty good curriculum. Belvedere School District, they also have money that maybe these other school districts, RPS 205, doesn't have to put towards this stuff. So that's kind of pushing this whole thing, is a lot of schools don't have the sources and resources to offer coding classes. And since it's not a required state requirement, they can't get funding. So they can't get funding, they can't hire a teacher, and so it's kind of dominoes. And so that's where this movement started in 2015. And I have seen since 2015, we're in 2019 now, I have seen students that have come from these programs or have taken the hour of code back in 2015 that have now taken our CIS courses. And, so it's kind of starting to see that exposure take to the next pathway for a career. Because a lot of times students, maybe even yourself, weren't exposed to a course level curriculum with coding until college. Maybe you didn't have it available, K through 12 possibly, I don't know. And it's not uncommon actually. And one of the audiences for guys, guys are prone by nature, we're prone to learn ourselves. We just take chances more, just proven. We're taught from a birth to take chances more. Women aren't the same as far as what they're taught. That's not an option. Coding is definitely not an option taught in their home or whatever. So one of the things I've been pushing a lot is pushing it in the K through 5, K through 6 area, the K through 8 area, is getting girls involved in coding at a younger age. That way because they have the math skills just like the guys do coming out of high school, and they have the technical skills to do it. They're just not given as an option, basically. Programming is not given as an option. Whereas guys, a lot of times that I get in programming classes, even though they didn't have programming in school, you started on your own at 10, 12, 11, whatever, to learn on your own. Whatever it would be, Scratch or Python or whatever, right? In fact, how many of you guys did a little bit of coding on your own in K through 12? You did it yourself. You just took it on yourself. You started learning. Okay, so about 5 or 6 of you in here. So that's pretty common. If we had women in here that asked the same question, probably maybe 1 at the most, if that would raise their hand that they tried it themselves. So anyway, That's Code for All. Code for All is the robotics side. It's also the Hour of Code side. And I thank the students. We have one in here that helped on Saturday. Thank you for helping on Saturday. And if you want to help on any of these upcoming, I'll need help. I know because I have 18 workshops slated between now and December. If you want to help with any of those 18, that would be awesome. It's 2 hours of your time, and maybe if you don't mind, I'll put you on the spot. You know, you're an entrepreneur, anyway. What would you say the benefit of a college student doing that, helping out other kids?
I think it's a benefit for them to have us there and helping them with problems that they would have with robots and things like that. And all you really do is show them how to read the code and things like that.
And did you have fun doing it, helping those kids? Yeah.
I didn't think I would.
No, I know you didn't. That's why I put you on the spot. But no, it's a lot of fun, and you get to see kids that come in, and the ones I see that I get the most out of is the ones who you can tell have never exposed to it. Maybe even it's scary to say this, or maybe not, but you can tell they've never even maybe touched a computer before, and they're like in 8th grade. They've never touched an electronic device to play with or do anything. They kind of feel scared, like they're going to break something. To see them going from that to the end, a finished product, like a finished lesson or whatever, and they completed it, and see them just get really excited about it. It kind of builds that confidence. Whether or not they become a programmer or not, really, to me, is a moot point. Is do they have the courage to learn something new and to try something new that maybe they've not tried before. So anyway, that's my little spill on learning robots and coding and Hour of Code. Cool. All right. Close these out. And if you're not following us on Twitter or Facebook, definitely do so, because you'll get prompted for those postings on the job site. And if you know any jobs at your workplace that's hiring, let me know. I'll post them for you for sure. Okay. So tonight's pointers, next week is read and write file in Replit. And then 12, we're going to update and play around with the dice game. That's going to be online. And then week 13, you'll work on your final lap on 13 and 14 both. I think I will probably be home those two, even though attendance is optional. I will probably be online both nights and just help people as needed on the chat or something like that, maybe. But if you need me to come in to help, I can definitely do that and sit down and help you. But I have no problem doing that. But we all will be here on the 15th to go over a checklist to make sure you have what's needed for your final lap, and then present on 5/6. So one of the things you'll be doing this week on pointers, we go to week 10. If I jump right to the assignment part, no, I don't want that. I think I put in there the final app resources part. This goes over the requirements for your app. Meter will need, comment through the code. If you use input, use validation, at least 3 functions, creating a web page in GitHub. There's links here how to create that. Screenshot on creating a web page in GitHub, uploading your code to GitHub. And these are just some dates that I'm not checking these, but making sure that maybe give you some timeline to go by. Along with some references to other games and apps that you could utilize. All right, let's go to 10 and start in the reading section. So chapter 15, Practical C++. And there's a slide link there I'll need you guys to click on, if you don't mind. That one says slides, share.nearpod or whatever. Click on that for me. It should ask you for your name, I think. And just type your name in and hit submit. And it should let you in. Hopefully, let me know if it doesn't. Hopefully, I can put the right code in there for you. I see Brandon's in, Drew's in. And you don't have to put your last name. I think it asks for full name or whatever, but you don't have to put full name in. That's fine. All right, who am I waiting on to get in? Anybody? Okay. All right, we're going to talk about pointers a little bit more detail tonight as far as what they are. We're going to use the concept of things when it comes to pointers. And this lesson goes over what the actual memory address looks like on a pointer. And you'll manipulate the set, some examples. We look at the second example we look at. The first example, we'll just do it to run it. Second example, I'll have you modify a little bit. But there are things, and then there are pointers to things, simply put, when it comes to pointers. And so you have here on the left side a thing, and that hexadecimal number is representative of a memory location in your computer. Okay? And the thing could be anything. It could be I don't know, a first name, last name. It could be a tax rate. It could be a student name, a student ID, whatever object is, whatever variable object is, the thing. And then the pointer is pointing to that thing throughout the application. And the benefit of using a pointer is once that reference is set in a pointer, it then doesn't have to be reinitiated. It's set in memory, doesn't have to be reallocated, and it's better on your memory resources to use pointers as much as possible in your code. And so you're still making normal variables, but once you make those variables and then you push it to a pointer, from that point on in your app, it uses a pointer reference to an exact memory location, and values of that value can be changed that's pointed to. And the pointer itself really is a very small footprint in the app. It's a very small footprint in the app compared to the actual variable, like a float or a double or an integer. So things become in any size. So again, integer, floats, doubles, strings all have certain sizes. They can be large and small. Some may be big. Some may be small as it becomes things. Pointers, though, are very small because we're really just referencing a memory location. That's all you're really doing. You're referencing a memory location. It grabs the variable name, gives it a memory location, and then from that point on in your app, you're then basically changing the variable by the pointer. If that makes sense. You're changing the thing by the pointer you've created to the thing throughout your app. Whereas without using pointers, every time you use that variable, it resizes that variable every instance in the compiler and builds in memory. It adds in the memory usage of that application. Whereas a pointer, if you use it initially on your app, and say it's, I don't know, a 100 KB variable, and you point to that 100 KB variable at the beginning of your app, that 100 KB variable that's used in a pointer will never grow past 100 KB. It'll just be reused over and over again in the application. So this example here gives a pointer assigning things addressed to the thing underscore pointer. And so in this example here, we have the word thing, and it's referencing the pointer, thing underscore pointer. And notice it's referencing just the memory address. That's all it's referencing. This one, other equals thing underscore pointer with an asterisk. This one remembers an ampersand. This one assigns to the other value the address of thing underscore pointer carries. And so it's basically going to whatever the address is, whatever it carries, is going to bring over into that other variable. And then the last one is assigning to a value to what the thing underscore pointer points to. And this is where the power comes in the last one, because you've declared the variable, you've referenced it, you pointed to it, and now you're able to, on the last example, modify that initial variable through the pointer. And it's not going to reinitialize it. It's not going to add that size to the app after that because it's locked in memory. And every time you run it, that memory location is going to be different. You'll see in a second when we run it in Replit, because I actually have it echoing out the actual memory location in the example we look at. So remember, a thing can be pretty good size, possibly. A pointer is relatively small in size. There's an example of using a pointer and referencing to a pointer. So we have in the first line here an integer called thing underscore variable var. It's a integer where we define a variable. Next is we define a pointer. We call it thing underscore pointer. It's an integer as well. Then the next line, we're taking that variable that's thing underscore var and assigning a value of 2 to that. And so if we do a C out, it should be thing should be 2 initially. And the next line, we make the pointer point to the thing underscore variable with that referencing code. The ampersand thing underscore var equals or pointing to the actual thing underscore pointer. And so basically on this one here, we're actually making the pointer become a part of the variable and grab onto the variable location of memory and even the value of that variable initially. So in this case, thing var has a value of 2, but really the power pointer comes in not the value of the variable, but the memory location. Because once it has that, it can then manipulate it. And it doesn't really help. The rules are still in place with the variable. So, you have to make sure when you declare a variable and a pointer for a variable, it has to be the same type of variable. So if it's an integer variable, it has to be an integer pointer. You can't have an integer variable and a float pointer. That would cause problems. Or a float integer and a integer pointer. Can't have that. The next line, where it's the asterisk thing underscore pointer equals 3, we've now changed the thing underscore var on that line dynamically with that memory location. And by the way, it's much faster, even though you're not going to be able to see it in your code. And with the CPU, that we have on our computer today, not really notice anything, but over time, it's a large application running a really fast loop or iteration. It can really save memory quite a bit, and memory leakage and things like that. And all memory leakage means is bad coding is all it is. It's just bad coding is all it is. Doesn't mean it doesn't work. It just means bad coding. You're just hitting a variable over and over again. And it's adding to that variable, that program every time in memory, more size. Then it's seen out here, thing variable should be 3. And another way of printing it could be thing, just printing out the actual pointer itself. So we would have thing 2, then thing 3, then thing 3. And we go back to the slide before. So seeing out the variable itself or the pointer itself that's been changed, but from the pointer here on this line here, this line right here. Either way, it's going to show the same data. As far as memory usage or better memory allocation on output, the latter is better because again, you're seeing out a memory location, and when it sees that, it doesn't have to go back and call in that variable again. It's right there. It's at the fingertips in the application. And it's much better on memory allocation and memory pull. So valid pointer declarations. So if we're pointing to a integer, and the I is off on that, by the way. It should be int, int star integer, asterisk IP, pointing to an integer, double, pointing to a double pointer, float FP, pointing to a float pointer, and then char CH with an asterisk in front of it, pointing to a char pointer. So the same type of variables you can do in normal variable declarations, you can do in pointers as well. So this basically gives another example of actual variable declaration here, which is int var equals 20, and then int pointer IP, and then the next line storing the address of var into the pointer IP with the ampersand symbol. So when we see out the value of var using var, it should be 20. Printing the address, IP, is going to be that hexadecimal value of that memory address. And then accessing the value of that pointer should also be 20, because it's going to bring in IP on this line here where it stores the address of the variable in there. It also gets a value as well. Reading, we'll go over this later, but there is a really quick quiz we're going to do. Very difficult. No, it's very easy. And so pointers come in one size: very large, over 10 megs, over 2 megs, or relatively small. What's the answer on that one? Pointers. Somebody tell me. We'll do it together. How many thinks B? How many think C? C is correct. Valid pointer declaration: float, ampersand price, float, asterisk price, float, pound price. How many thinks A? How many thinks C? How many thinks B? B is correct. This will always be how you declare a pointer. Remember, this is how you're assigning a variable to a pointer. So you have pointer name equals, that's what you would use to assign it. Assigning a pointer to a variable, example, float item price, float price. So in this one here, we have price is going to be a float. And for whatever reason, that didn't show up right. Let me see if I can get it now. Not going to show up right on that either. So price basically is a pointer. Price is the pointer in this case. Item price is a variable. So if we're going to assign a pointer to a variable, is it going to be like this? And remember, this is a pointer, this is a variable. It's going to be like this, this, or this. How many thinks C? How many thinks B? How many thinks A? A is correct, remember, because we have the ampersand. Ampersand in front of the variable to the left of the pointer is what we're going to do. Remember, that's going to take the variable item price and point it to that variable price, and now it's going to become a part of that application. So submit that, and then go back to the tab to the left. And I will exit out of this. Everybody should have got 3 out of 3 on that, hopefully. All right, I'm going to exit out of my tab here. All right. First example inside of week 10 example is this one here, the return pointer. So if you click on that, you should see this here. All right, we'll go over the code first and we'll run it. In here, we're going to, again, use pointers for sure. So in the first line in the main, we're declaring 2 integers and an I, and then 2 floats, average and sum, and then asking the user to enter in how many numbers they were going to enter in. It's going to average basically these numbers when we're done. They enter that number, let's say 2, enter each number and then do a return key. So it's going to, on this line 11, declare a float array, and n is going to be in there. So if they put 2 in there, it should be float of 2, 0 and 1. And then the for loop, it's going to for loop 0, for loop 1, and ask for them to input the first number, then the second number. Then it's going to the second for loop, same exact for loop, except this time we're summing together the value of the input, number 1 and number 2. Line 22, we're averaging it with sum divided by n, 2, plug it into average. And then line 23, we're taking the variable average and putting it to the pointer. It's been declared here. Then on line 26, we're kicking out just the pointer. Average number in the array is pointer. So let's go ahead and run it. And you can put in whatever number you want to. I'm going to go ahead and put in 3 on how many numbers I'm going to do. And I'm going to put in 1 number per line and enter, or return after each number. So I'll put in 10, 15, and 20. The average of those 3 numbers is 15. Pretty simple, right? So all it does is average the numbers and displays it. You don't really see any memory output here, but we will in the next example. So let's go to the next example here, which is this pointer example. And there is an answer one we'll look at later if you need it. Let's go to this one here. And this one's a little bit more, you definitely would do this in your application. It's more for learning purposes, showing you what it's doing with the pointers. So on this one here, we're declaring some strings first. We have, and these strings are pointers, 2 string pointers, one called RBC student name underscore pointer, and RBC student ID underscore pointer. Then 2 more strings, one for the value of the student name, the ID value of the student. Then a variable to hold the string of the student name. Then a variable to hold the string of student ID. Then seeing that out here. Then the next line, assigning the variable RBC student name to the pointer, RBC student name pointer. Next line, assigning RBC student ID to RBC student ID underscore pointer. Then line 26 or 27, doing a C out for the address of the RBC student name underscore pointer. Then line 29, doing a C out of the address of the RBC student under ID underscore pointer. Student ID underscore pointer. Then 31, assigning the value of the pointer RBC student name underscore pointer to the RBC name underscore value. So it's reversing it back to that variable RBC name value. Then line 34, assigning the value of pointer RBC student to the value RBC student ID underscore value. Then seeing that out on line 36. So we'll run this, and then we'll have you do some other stuff on the challenge part. So I'll go ahead and run it. You'll notice when I run this, your memory address will change. Like it's Elvis Presley, then 0, 1, 2, 3, 4, 5, 6, 7. The address for RBC student name is at OX7 FFE7B2 C7810. Now, if I run this again, it'll change that memory location on all the addresses for those pointers, for both the student RBC student name underscore pointer and RBC student ID underscore pointer. So this is dynamically grabbing it, just showing you how it's dynamically grabbing that location memory every time in the program. And then this is just kicking out the value of it. So what you're going to do basically is complete stuff that's already been done for you, by the way, which is RBC student 1 has already been declared at the top of the code. And so what you're going to be doing is assigning RBC student name underscore pointer to your name, assigning RBC student underscore pointer to the RBC student name pointer. So just follow the directions on that and use the above to help you that we did here. You're just doing copy and pasting. So instead of Elvis Presley, it's going to be your name, basically. Let's go ahead and do that. And there is an answer link there to help you as well. But we'll see how you do without it. There's usually an example above you, but okay. So I'll tell you in the comments exactly what to do on that. Declaration for RBC student 1, you're just copy and pasting above the, I think it's lines 8 through 14, I think is what it is, of the normal declarations. You just copy and paste it, put 1 at the end of that. Put RBC student name down to RBC student ID underscore value. Okay, that's all right. So, get the last page. Let's see. Okay. One more. Yeah, we'll go over this real quick. One more to go over. Okay, so let me switch screen here. All right, so let's go to the very top of the first page. We're declaring the variables for RBC student 1. You could have just copy and pasted the RBC student data from, what was it, 8 through 14, those variables. Boom, put the number 1 in there after RBC student. Then jump down to line 51, which is, let's see on your paper, what page is that? Probably page 2. Yeah, page 2. So I'll look at page 2 to where you see the RBC student 1, setting up RBC student 1. Should say complete for RBC student 1, assign RBC student name pointer to your name. So I put in Chuck Conkle, you put in your name. Then the next one was assign RBC student name underscore pointer to the RBC student 1 name. That's this line here. So Chuck Conkle now is part of RBC student 1 name underscore pointer. Then assign RBC student name underscore pointer to the RBC student 1 name value. Then assigning the RBC student underscore pointer to the 7-digit ID. Then assigning that pointer to the RBC1 pointer, ID pointer. Then assigning the RBC student ID pointer to the RBC student 1 ID value. Then doing a C out to find the address for RBC student 1 name underscore pointer. Then find the address for RBC student 1 ID underscore pointer. So these first two are just the pointer addresses. And then the last two are the values for the name and ID. So if I go ahead and run the app and you run yours, it should give the that data. Yeah, there we go. Got a new version of Replit set on mine, so I'm going to restart it here. Just a formatting, it looks like. How many input files? Messed up here. Did an enter key when I copy and paste, I think, for you guys what I did. Okay. Did an enter key somewhere here. Hang on a second. Good, good. There we go. Yeah.
So when assigning a pointer to another pointer,
Right, correct. Well, you don't need the asterisk, right? You don't need the asterisk. You also don't need the asterisk. Once it's already been assigned as a pointer reference, you don't need to put the pointer in front of it every time. After that, you don't have to. Oh, I did something wrong here. Do what now? That's what line? Student ID. Is that sign up? Do what now? The second one or the first one? 52? I don't think so, but no. I think I just said enter somewhere on my code whenever I copy and pasted your code earlier. All right, let's see. I'll find it. Let me make sure this one's running. I messed it all up. Do I know? Yeah, I did something on the copy, I think. Get rid of that. I'm gonna reload it. Loading. That's weird. It's got two files in here or something. Yeah, something screwed up. Don't know. Pretty standard. Okay, none of my examples are running now. I crashed Replit. Anyway, is your guys working on your end? Just me, probably, right? Okay, that's fine. I crashed it. Anyway, you got the handout on it. That should function. You get on the pointers, basically, what we're talking about. I'll bring up this sheet here. It'd be easier probably than the code since my replic's not working. So once you assign something as a pointer, like in this case here, RVC student name underscore pointer, when it's utilized below, let's see here, right there, you don't have to put the asterisk in front of it. Somebody asked that earlier. Same way also on the reverse here. The reason you do it here is to tell the name that you're pointing to it, the actual value of the pointer instead of the memory reference. The value of the pointer instead of the memory reference. Here, it's just the address of the pointer or address of the variable name. That's why we don't need the asterisk. You need the asterisk whenever you're bringing in the value of the pointer, to answer your question earlier. So value of the pointer, bringing into a variable, needs the asterisk. If you're bringing a reference of a variable into a pointer for just a memory location, you don't need the asterisk.
I was talking about the line of when I did it.
Yep.
Your previous memory. After you put in the next line you typed out.
Right. So up here?
2 lines below that.
Right here?
The line above that.
This one here?
Yeah.
Yep. Yeah, pointer to pointer. We're just doing a pointer of the name. Well, in this case, it's Chuck Conkle to student 1 pointer is all it is. And this is actually pointing to the, assigning the name pointer to the Chuck Conkle to that new pointer, which is the value in this case. Did you get an error on yours when you did it?
Still talking about different lines.
Huh?
Still talking about different lines. On the line above that one.
This line?
Nope. Down to.
This one?
No. Up.
This one?
Yes.
Okay. All right.
I put in asterisks at the.
Oh, okay. Okay. You put an asterisk here.
Yeah.
Okay. Yeah, in that case, you're going to be, it should matter. It shouldn't matter on it. Yeah, should matter on it. Good question. So basically, the pointers are going to be referencing a value of the pointer or the memory address of the pointer. Does that make sense? And so when you're referencing the value of a pointer, you have to have the asterisk in there. If you don't want the value, but you want the reference of the memory, you leave the asterisk in. Cool. Any other questions on that? Cool. All right, let's go next. The homework for this week is we're going to be doing a max value. Bring it up here. I did complete everybody's up to today anyway. So on this one here, you're going to write a C++ program to find the max of a number in a set. So we'll be using what's called the max value. We'll ask the user to input a number of values in each value. The program will print on the screen a pointer to that points to that max value. And so if you enter in, say, 3 numbers, and you enter in 12, 23, 56, it's going to kick out the largest number, 56. And 56, or where it's kicking out this value here, is where it's printing out to the screen from a pointer to that value. And so I put in here a reference to max and min, which we'll look at. Okay, so I'll go ahead and run it. Yeah, my rep was totally screwed up. So let me close out repo altogether. Sorry about that. Log out of myself and try it this way now. There we go. Okay. Oh my gosh. Nothing's working. All right. All my repos not working. Wow. Okay. Try a different browser, I guess. Maybe it's Chrome. Okay, that works. Firefox worked. All right, so this example gives how to find the max value and min value both of numbers. And so in the main, I've got 100 and 200 integers, and then a variable called ret that's an integer, and calling a function called max that brings in a and b. And we'll look at that real quick. And so all we're doing on this is referring back to num1 and num2, int results. If num1 is greater than num2, that's going to be the max. Else the other one's going to be max, and returns it. On the min function, it's if num1 is less than num2. Find the min and max. But for this example, for your assignment, you just need to find the max value only. While we're in there, let's see if I can log in my login. Wrong one. Make sure it's not my compiler didn't crash. No. Still getting it. Oh, still happening on Firefox too. Okay, I'll have to look into that. But anyway, the max value, you're going to use the same logic we used tonight on pointers, but you're going to kick back at the end of the logic and those functions. In this case, you're just getting a return of a max value and however many numbers it is, and then kicking back that largest number in that array with an actual pointer. And so in order to do that from your handout, you're going to declare a pointer value. And in this case, it's going to have to be for a max value. You can do, I would say probably a float would be a good one on this, or a double. Either one would work. Float or a double. For the output on numbers, where it says enter how many numbers, what do you think? What type of variable do you think that should be? When we're declaring variable types to determine on CN. For this variable here, what should it be? Integer. Then these three numbers, let's say 3, the variables you're declaring for that should be either float or double. And then to come back with the answer, all you want to do is point to the pointer value, not the pointer address, but the value of that pointer of that variable. And remember, when you're doing a value pointer, so if we do, like, say, for instance, float, call it float result. When you're bringing in the value of that into like the ampersand of num, that's a beautiful ampersand, into the actual result. That's going to plug it into now the memory location as well as the value into the pointer result. And with result, you can then kick out either the memory location or the value. In this case, we want the value only. Cool? Questions on that? All right, let's go back. And I also put a reminder in here on your requirements for your final app. If you could work on that this week as well, because it will creep up on you pretty quick. This one, you're going to define pointer in chapter 15 on C++. 7 questions on that. And then, what is your favorite mobile app and why? Especially since we're getting more towards the final app working example that you're working on. It's a good idea to kind of get a feel for what people's favorite apps is. What's your guys' favorite app that you work with every day with your phone? What is it? What was it now? Your app. What about you? What's your favorite mobile app? What is it? What game is it? What is it now? Sweet. Pretty popular. Like it. What about you?
Twitch. Twitch.tv.
Twitch. Yeah. Oh yeah, that's popular. I was watching weekly podcasts with those guys. Yeah. Anybody else? No? No favorite mobile apps? What's it again? Dashlane?
Dashlane. It's a password.
The store password? Yeah. Okay. Sweet. Yeah, you have to remember passwords like me. Yeah, you forget them sometimes. Good. So you just kind of get a feel for what everybody's favorite app is, and maybe get an idea for an app to try or a game, right? I don't know if you heard today in the news, the Apple did their yearly rollout of their changes. One of them in the App Store, they're doing arcade. An arcade tab now will be in the App Store, where you can pay a monthly fee for the arcade and then play any of the games unlimited that's in that arcade tab, versus the in-app purchases, which is real popular. And so you want to do that anymore. And so that'll be kind of cool. The question I had was, as a developer, can you ask for, as one of the categories, to be added to that arcade app category? I don't know. From what I understood from the announcement, it was a group of people in Apple that will decide what apps get to go into that arcade tab. Because it can rack up pretty quick, especially those of you who play games on the in-app purchases, or the in-app purchases not just within the app, but within different levels of the app or different objects of the app. This way, if it's a EA game, which that's a popular one they're going to be adding into this, there'll be no in-app purchases for that game once it's been purchased in the subscription. So once it's in there, you play it unlimited. So that'll be kind of cool. Then some of the newer updates was Apple TV is now adding true TV channels to the TV. And then Apple Card, an Apple credit card, I believe, is the other one. And for developers, they're going to make it to where we get higher return on the apps in the App Store. That'll be pretty good. And then that's about it. There's a number of other ones, but that's about it. So, all right, well, that's all I have this week. My voice is about ready to go, as you can see. If you have any questions on anything, come and see me. Also, if you want to come play with this IoT device, you can definitely do that. And yes. What is it now?
I've worked is hiring.
Okay. Oh, great. Oh, sweet. Yeah. You sent me an email on it?
Yeah.
All right, cool. Thank you. We'll definitely do that. Cool. You guys have a good week. Yes, sir. Oh, the QR?
Yeah.
Yeah, I can help you with that.
I also sent you about one time we had a conversation about, like a company that are doing not scholarships, they're doing like internships. For
Internship, yeah.
You didn't get back to me yet.
Okay. What was it? Was it a company in town, or just like in general internship?
I really forgot, but it has to do with like internships and stuff.
Oh, that was Illuminato, right? Illuminato.io. Yeah, that gentleman had not got back from me. Yeah, I did get that email from you. And I hadn't heard back from him. And so shoot me another email. I'll send another reminder. He's super busy. First three characters of your first name?
I am.
There we go. Is that correct? I'll take a picture of that. Yep. All right. You want to play with the IoT device? Why not, right?
Oh.
All you have to do is tap on that. Tap on the button that says temp. It'll change it from text to temp. And then tap on it again, and it'll go back to the text. And then if you put your mouth or finger in that little text box there,
yeah,
just go and type in whatever. It doesn't matter. You type in law or whatever.
I only have one question about these devices.
Sure.
The way that you okay, you write the code down and everything else. You have the hardware too. How do you put the code in the hardware?
That has a thing called publish. What it does, there's a Particle has a website. Once you get your code updated, you publish it and it syncs it to that device. It flashes it with the code basically. So the code's
so you
actually
don't actually do like every single step for like putting that in the hardware, because I know like there was like a lot of work involved in like getting the code like embedded in the hardware.
No, the what's already built in the hardware is the authentication piece, the Wi-Fi piece. That's already built in, and then Particle has, you can pretty much push any type of notification in your code that you build to that device. So there's some wrappers already built in, some libraries already built in to the static hardware, so where you don't have to code it from scratch. No, you don't. Which makes it great for a programmer because you can just get it and then start programming what you want it to do immediately. So the base part's already taken care of, if that makes sense.
Yeah.
So, cool. Awesome.
All right.
All right. Yeah, you too. Hey, do you want to play this IoT thing? You want to play this IoT thing? You good? Okay. Didn't know if you'd ever seen it before.
I've messed with them.
Do I now?
I've messed with it.
Yep. Okay, cool. I'll go ahead and turn it off then.
I have the homework assignment done, but it seems like there's one small comes up wrong.
What's that?
I've been done, but like 1 out of like 50.
I would blame it on Replit. If I was to blame it on something, just like I had issues with mine. Every once in a while I've seen it made a lot of changes on Replit. And have a lot of code-based changes for people to make games. Well, just like tonight, you notice it showed you had set up database Replit. They used to do that. So I think they make a lot of changes. If I was to guess when it does the incorrect output moves, it's those type of bugs. So if it's outputting once correctly, Replit outputs incorrectly after that, it's not your code, it's Replit. So it's like on my ear, I was getting on what you cannot find input and ask for it. Such a picture. So, yeah, no, I wouldn't, it's not your code, it's Replit. I've seen the same thing. It's not really built for productivity apps. It's more built for learn this concept, see how it works, compile it, move on. Makes sense. So, in a productivity app, you're right, it's going to be constantly hitting it every second or something. That's unbelievable. If you're sitting there, if you're going to run like a game or something, or just iteration, it could fail probably out of 20 times, it probably failed once or twice, I'm guessing. on the load. This is what's happening. Is it coming on the load or just on the output?
It's on the output. Like the wrong path.
It's my experience with Replit, and it looks like my I make the libraries get messed up in that C++ compiler, and they and that's why in that case of yours, I've seen it. I'm guessing they've never said this, but like on your different types of variables, where I've seen a float actually act like a default and a default. Periodic. So I don't know if that's what's happening in your case. There's a float type conversion, which means a different output. That's a float type conversion. That can make sense too. You know, the variable. So say it's supposed to be a double, and it gives like a 1/6e, something like that. That's an exploitation. It's giving float. Yeah, I've seen the compiler do that, so it's not uncommon. It's not your code. Yeah, it's not your program, no. If it's programming right, which yours have been perfect. If it's programming right the first time, and compiling right the first time, you're good. Yeah, because really, if you iterate beyond that, or try to push it, you will break Replit. It'll happen. I think they might do that on purpose, actually. Probably they did. I'm thinking one of the reasons they do probably, since it's free, let's say it was really robust, was to say some person couldn't put in some type of code or application. Because it's public, once you share it, they can share it in a production environment. It's an easy one. I think they make those fails. Again, they've not said this in any I think one way to stop developers from abusing it is by doing so. Which makes sense. It's free. I mean, we're not paying for it. So just something for learning. But again, they've never said that, but I wouldn't be surprised if they have some type of algorithm in there. If they see an app running so many times, so many iterations, and so much period of time, they might throw in there some wrenches. Just so the developer won't release it for some type of public. That makes sense. I'm guessing that's probably what they're doing. So cool. Yep. And if you want, there is other. If you're wanting it as a more of a public type of app or a production type of app, there are other engines that I can give you that I use that are in the production side, but are free for developers that are more robust. So it'll give you like 1 million hits. One of them gives like 1 million hits per app per every 60 seconds at no cost. And then if you go beyond that, like in gaming, you go beyond that, then you have to pay so much for that online game application that you create. So if you're interested in something like that, let me know. I can shoot you some data of free resources to share your app for a more production environment, like for a game or something.
Okay, good.
Yeah. Because it sounds like it might what you want to do. Maybe it sounds like maybe.
What's the extent that you can? What's the extent that you can do? Like how?
Let's talk brass tacks here as far as everyday programming. You're a gamer, right? You like games, mobile app games. 99% of mobile app games are you an Android guy or an iOS guy? Android. I teach an Android world. I teach Kotlin. So 99% of new apps created today are Kotlin. If you're an iOS guy, it's Swift. Most companies are going to do both. So if they create an app, it's going to be both worlds. And so as a developer, you're going to be developing mainly in Swift and in Kotlin, those two languages in the mobile world. In the desktop world, which is kind of going, it's kind of merging with mobile, C# is still very popular when it comes to the desktop world. And then IoT world, Python. C++ still has a place, but it's kind of, I'm not saying it's not. I'm not saying it's archaic yet, but what I see it used for mainly for programmers is logic. It gives you good logic base for any language. Like back when Counter-Strike first came out, I taught C++ in high school. All the levels of Counter-Strike were done in C++. And they would give you download an engine, and then they put you on levels and maps. I think it's what they call it, Counter-Strike. Control maps. Went from that to C#, and also C#, and then there are even advanced levels now of gaming in just pure JavaScript and Python. Those are real powerful, like Minecraft. Minecraft told backend, Python, Black Ops. You want to know?
I thought Minecraft.
Python. It's written in Python, and it does have JavaScript. The main basic of Minecraft. But like point-and-shoot games, first-person shooter games today, a lot of them are high-end. Unity is a popular platform to build games on, and on Unity, you can use C++. More than likely, most people know C# or Python. And Unity is just a game engine I've heard of. It's like games and gives you a good 2D, 3D platform for them. The C++ is, in my mind, you always have need for it in some, like I use a lot for a back end for data retrieval, data updates, because it runs in very low latency. It doesn't use a lot of processing power. So you see a lot of C++ games use that for that purpose, like it we use to drive the levels, the scoreboard, but not everything, just maybe things like that. And then the actual meat of the app might be switching over to Python, switching over years to JavaScript, switching over years to more on the mobile side Swift, and then Kotlin. And Kotlin's one of the newer languages. It became an official Android language 2.5 years ago for us. It's now surpassing Java. So yeah, to answer your question, it's still used, but when a new game developer creates a new game, and more than likely, like EA games, it's going to be on both the iOS and Android. It's all that's out there. So we're going to be developing Kotlin and Swift. You know, when I first started programming for iOS, it was Objective-C. There's still a handful of apps out there in Objective-C that I've not converted, and I probably won't, unless Apple forces us to. It's just too much work. But any new apps,
even then, like, everyone's taking HTML5 this semester. Use an example of you, had like a education company,
yeah,
and then Google forced everyone. Was it to make the website like message?
Yeah.
Skip it.
Yeah. Oh, yeah, exactly. And there's going to be some cases where you're just going to say, forget it, I'm going to do it. But then there's on anything new, yeah, it's a no-brainer. You're going to use the newest and greatest. But older apps or archaic apps, nah. Like an example was Dropbox, which is a popular data store for a lot of these apps. They changed all of their APIs for storing data last year. I did have to redo, this app here, which is on the App Store. I had to redo that because I let it go as long as it could. So literally, they had a cutoff date, which I usually do. You said, okay, after this cutoff date, it's not going to work. Well, I went into the very last minute, like the week of, before I started changing it. But I thought, well, it'll only take me 5 minutes. Well, it took me like 5 days, but whatever. But yeah, the benefit of using new languages in my mind is longevity, which would definitely be Swift, Kotlin, C Sharp. Those three are the top three. Python. Python's another one to learn if you haven't. Because those four languages are JavaScript also. JavaScript is also going to be one. It's in every type of that. That's a fun language too. Self-taught.
I did a little, like when I first got into programming.
Sure.
Those were JavaScript.
Yeah.
Those I had.
If you send me a link, I do that JavaScript course online now, and it is face to face, but it's all on GitHub, all the lessons, and I'll send it to you. It just gives a lesson by lesson in JavaScript. Some of that Google Slides, some of you don't. Basically, you're building a grocery shopping app that you can share with anybody once you're done. It creates a Bitly link of that app, and when you share it to somebody, like your friend, your mom, dad, whatever, brother, sister, they load it on their phone, and then they can check off as they have the items. That's the app I use in class because it uses everything you should need to know in JavaScript: database, technology, JavaScript, reading and writing files, updating files, which JavaScript is really good at doing as a client-based app on phones even. So, but anyway, one of the ones that I think you mentioned earlier, HTML5 was the one that now blocks, and all browsers pretty much by default. ActiveX was a real popular web language years ago, and Flash was popular as well. It's kind of on the wayside.
Oh, that's good to say. Because
Yeah.
that's the problem with having apps on another platform like Dropbox. Now
Yep.
that's pretty much gone. That's Apple.
Yep.
A version of Dropbox.
Yep, exactly. Yep, and that's one of the reasons why I had to change this. They have their own cloud-based iCloud, is what they call it, for their back-end data store. You can still use Dropbox, but then you have to change it like I had to do. So, and the reason I used Dropbox on this one, it's like 5 years old, was Apple didn't have a tool, data tool anyway, for developers to use at that time, a cloud tool, so they all developed had to use Dropbox. So, but yeah, to answer your question, though, hopefully that probably getting more than what you want to know. But yeah, C++ is still used a lot, just not to the extent it was, say, 18 years ago in new app development.
In terms of applications.
Yeah, as far as understanding, that's why a lot of universities and colleges teach it, is it's a good foundation for all programming languages. C++ is. That's why it's always, in every college, pretty much, any community college, university, whatever, when it comes to programming certificates or degrees, you'll always see C++ in there. That's the intro foundational course, and usually even intermediate. But you'll also see now creeping in mobile, because that's predominantly what is shifting both in business and also in the private sector, mobile apps. Companies pretty much are making any money in software development on the mobile side. Not saying not making on the desktop side, it's just the most money and the most growth is happening on the side. Exactly. Companies, and including, where say they did have a desktop app years ago, the company still exists, but it's now went from a desktop app to maybe a web app, where it's not, they don't install anything on clients.
Even then, about 80% of the site, it's
Yeah, exactly. Yeah, you're right. And the reason for that is 80% of users have that in their hand already, both at work and home. I mean, now I'm on a computer all day just because I program all day. But most people that are in sales or marketing or any other field, they don't need a desktop. You know, tablet or phone. So really, I think we'll get to a place to where the only people in business that will need a desktop or laptop, a workhorse device, would be developers. Think about it. Because everybody else will need it. Got enough power in every type of tablet that's out there today, not all the apps that's needed. I mean, even AutoCAD, which is a huge app for engineering, it now even runs on tablets now. And so, whereas 2 years ago, that wasn't the case. But the processors are such on these tablets now where they can run it. They can run it. Multi-processing and kick out the apps, drawings, just like it would on a powerful desktop. No, it's just because of shift. I think it was 2 years ago, mobile devices and tablets outsold desktop and laptops. That's 2 years old stat. So it's just exponentially increasing every month. When the company goes to buy all new computers, they're rethinking what they're buying. Going from traditional desktop to maybe a tablet or something. A couple of reasons: it's more cost effective. Secondly, there's more apps available that they can use. Usually a cheaper rate than they can a lot of times. Desktop. A lot of the apps in desktop since 64-bit came in have become antiquated. That's the old apps, 32-bit, there's even 16-bit apps that are out there. Not on 64-bit. So that means that's good for developers though, because we have to convert those to the newest and greatest. There's a lot of companies are saying, I'm just going to convert to mobile. Cool. All right, man. It's good talking to you. Sorry about my voice, by the way. I don't think I have anything. I just don't know what it was. It's going hoarse or something. Hopefully I'm not coming down with anything. I don't want to.